Hello, all. Let's start with our today's DSA Journey with this amazing DSA platform. Use this link to get a 7-day free trial. Let's start with our today's DSA, and today we will start the link list. Okay, so linked list is a linear data structure. In linked list, we just don't store value. We store value with the pointer to the next node. Okay, so a typical linked list look like this. So this is a typical linked list. So the head of this linked list is this one, and this all are, okay. This all are nodes. The whole thing that take it. The whole thing is consist of one node, and one node contain two things. One is what is the value, and another one index or pointer, not index, or pointer of, or rather call it an address of next node. So this box, this arrow actually contain the address of the next node. If this point at 100 and this point at the address location of 200, this box contain 200, because this 200 is the address of this next node. Okay, so this is how linked list actually work. It is a linear data structure, but other than array, it is a linear data structure. Also it stored its value and the address of the next value. Okay, and the last one we put a crosshair. It is nothing but a null. So when we point a null here, it simply means the list end here. Also we had a pointer as head, so this indicate where our node get started. So in this two, our linked list started, this null our linked list end. Okay, so every node, the whole the thing is a node. Every node contain two things, one value and another one is the address of the next node. Okay, it is the single linked list. Okay, and we have to go through the question to solve this. So our first question is reverse a linked list. Given a head of the singly linked list, reverse the list and return the new head. Okay. So this is a singly linked list. So what is a singly linked list? A singly linked list simply return simply as this one. Value, we have addresses, we have value, we have addresses. Way in a single structure. Okay, in doubly linked list we can have point like this, but that is a different thing. This is called a singly linked list. We are given a head, we have to reverse it. Okay, we have to reverse it and make sure our new linked list look like this 5, then this 3, then this 2, this 2. Okay, so our new head is this. So we have to convert our linked list from this to this. Okay, so how could we actually do this? Okay, so here are mostly two type of solution exist. One is a three-pointer approach, another one is recursive. So let's start with our three-pointer approach. Okay, and the three-pointer approach actually the most popular one, and most of them use it. Recursive approach used by many fewer ones, but also is a very good approach. So this is our one node. Let's suppose it as 2. Okay, this is a one node. Let me just copy this. Okay, let's take this. Okay, let's delete this, guys. Okay, so now let's take it as 5, then 9. Okay, this is the pointers pointing towards a null. Okay, our current head. So, okay, so now how we can use it? So the one of the good approaches, this is our link list. This is our link list. So one of the good approaches is we can use 3 pointers, and we just move it in a that it should always go and reverse the list. How can we actually do this? Let's do it. So we will take 3 pointers. Okay, one is current. Let's take it as C. Another one is previous. Okay, this current holds the current node. This current holds the current node. Also, the previous hold the previous node of the current node. Okay, it holds the previous node of the current nodes. And also we need a forward holds the next node of the current node. Okay, so the P should come. Okay, so this is this previous node, current node at the starting pointing towards head. Okay, and the previous pointing towards null, and the forward also pointing towards null, but we will assign forward next. Okay, so this is our current node. And now what is the meaning of the forward node? The forward node simply means that the next node. So this is our node. So this forward node always have the current next. This forward node always have the current next and current reaches this null. Okay, and what is the previous? Previous always have this previous one. Okay, so suppose this is our previous null. So for now current is in the head or the first node. Forward is the next node of the current node, and the previous is the previous one. Also we don't have any previous, so we just simply go and put the previous into the null. Okay, now if we go this forward, rather than just take f here. Yes, this f is forward node. This is the current node, and this is the previous node. Did it? The previous, this is the current, this is the forward. Okay, now at the starting we initialize this forward to the next node. Okay, now for a reverse array, okay, for a reverse linked list, what is the reverse of this linked list? Okay, let's do it. So this is our linked list. So our linked list is 2 5. I just put the values here, not the indexes. 2 5 8 9. Okay, so what is the reverse linked list? 9, or rather if we just change the points. Okay, 9 to 8, 8 to 5, 5 to 2, and we just put head here and put head at the last. Okay, and this point towards null, and we just put this point towards null. If we somehow let's take an understand, if we somehow this point or this address, if we somehow change this address or these points, then we can easily reverse it. Okay, so 2 to 5 is our point. Okay, so if we somehow point this, because this is our point. Okay, now if we somehow point this, so this is the reverse one here, so this is the reverse one here, you can clearly see this is the one, and we just have to just flip the pointers. Okay, so flip the pointers. How could we flip the pointers? So simply 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 the current. So what should this pointer goes, this two goes to the null. Okay, these two, the pointer of these two at the first we just put it towards 5, but at the end it just go towards this cross sign. Okay, so these two pointers should go to a null. So what is now null here? This previous one. This previous is now currently holding the null. So these two points towards this cross, and we just remove this pointer. We can easily remove this. And maybe you thought, we just lost our linked list. No, because the remaining linked list is now attached with this f pointer, and this part attached with this c and this p part. Okay, so simply you could say, you when you put when you cut the link and put it towards previous, it goes to the next previous element. Okay, now simply move previous to the current, okay, and now move this current towards forward. Okay, so now p pointing this, c pointing this. See this whole linked list, the remaining part, this remaining part actually now pointed with c, and this remaining part or the left part is pointed with p. So we have uh, pointed both of the linked list, and we can easily move it. So we just simply move the same thing. What we did three things. First, we point our current here. Okay, now the forward goes to the current next. Okay, so now 5 and 8, so in reverse 8 should point to 5. Okay, and 5 should point to 2. What is now 5 pointing towards 8? So we just have to remove this. And what is our point? 5 should point towards the previous. 5 should point towards the previous, as we do it previously. Now we just move our previous to here and our current to here. Okay. So see, this remaining part is now holding with C, and this left part is now connected with this P, because 5 pointed to 2, 2 pointed to null. Now this C, we have a C or a current, and now the forward is this. Okay, now 8 pointing towards 9. Okay, we just delete it. And this C now pointed towards P. Move P here, then goes C here. Okay, and now P hold this, C hold this. Now what is the forward? Forward is null. No matter, we don't check about forward. Is this point in a right portion? No. We just take the point and move it towards previous. Now simply we just move our P, move our C. Now C is pointing at null. When C pointed at null, we have to stop and return our P. Here if you see the question, return the new head. Our new head is actually P. Okay. So let's see P, if the P is at 9, 8, 5, 2, null. 9, 8, 5, 2, null. Simply with the help of three pointers, we simply achieve a state where we simply reverse a singly linked list. So if we go to the visualization, see, this is current, this is next. Okay, why I don't take next here? Because sometimes the next actually pointing towards the next address of the next node. Okay, so for that reason I take forward. I just don't take next, although it will not like difference so many things, but I just do it for a naming convention and nothing else. Okay, so now the current, the previous is actually null. See, this previous is null, current is node 0, next is node 1. Okay, node 0, node 1. Previous pointed to null, current pointed to 1. Now the previous is 0, current is 1, next is 2. Point 1 to 0. Simply the same thing we do there is the simply. And at the end, we have to just reverse the previous, because previous pointed towards the head of the reverse linked list. So let's write down this. So we are actually given a function. Let's suppose we are given a head. We actually given a head in the question. So we will use three pointers. First, we need a current pointers which pointing towards head, and we need another pointer which is previous, which pointing towards at the starting null. Okay. Although we have to run the loop till we reach the end, and how we reach the end? Till the current is not equal to null. Okay, now we need a next index or a next pointer which is forward of this current, which is current next. Okay, so next is actually store the address of the next node. So for this I take the pointer as forward, but here they are also taking this here. Okay, uh, now we have to move our previous, our current address to our previous one. Okay, so the current next is moving towards previous. This line actually revert the pointers towards the previous one. Okay, so if we clearly see, when this step happen, this pointer, see this black line from 4 to 5 actually move 4 to 3. This line actually does this. So our current is at okay, sorry, our current is at 4. So 4 to 5 we have to point 4 to 3. Okay, so this line actually does this thing, this one. The 4 pointed towards 5, now 4 pointed towards 3. This line actually does this. Now we have to increase our previous. Okay, see, the previous already moves towards 4, towards this element 4, and so we have to do this. It is nothing but previous equal to current. So we just move our previous, and then we have to increase our current also. So it is simply current equal to forward, and just return the previous, because previous is our current head. We see here the previous actually stored this head. Yes, we done it. Let's go to lead code and solve it. Same question. See here, integer value and integer star list node start next. Okay, so next is our address and val is our actual value. Okay, we need first we need three pointers. Uh, Current and previous at the first. So the pointer type would be list node type. Okay, so our list node type pointer, first we need a current which is pointing towards the head, and another list node type we need, and we need one as a previous, okay, which is at the starting pointed towards null. But for doing everything we have to check one thing, and let's do it here also. Suppose we are given a linked list. 5 is our value, this is our head, this is our pointer. This is also a linked list. This is also a linked list. And also list because it has no value. It pointed the head pointing towards null. So for these two cases, this case and this case, where only one node available and where no node is there. So there are two types, only one node and no node. So for these two cases, does we have to actually reverse it, or can we have to reverse it? Because we have only one value here. Let's suppose this one node. So for this one node, we have only one value. So when we have only one value, we don't need to reverse it. Also, when we have no values, how could we reverse it? And let's see the question here. Return the reversed linked list, but how could we return the reversed linked list? We have to return the reversed linked list head, which is previous here. So does we need three pointers when we have only one node or two node? No. We actually don't have to perform any operation if we have only one node or two node. So for that reason, what will be our answer? This head only, because this head pointing towards a null. So this head is always pointing towards a null, if it is reverse or not. This head pointing at node 5, okay, this 5. So if we reverse it, this will also point to node 5, and we have to actually give the or return the head of this node 5, which is head, and for the here also which is head. So for those two cases, we need to ensure that. So our head next is equal to null. So this is for this one node concept. The head next is null, or the head is equal to null. So for this is for this no node value. So one node we have this one node which is head next not equal to null, and for this we have no node, so head is equal to null. For these two cases, just return the head, for these two cases. And this while we have to now traverse the array, okay. So simply we have to move and perform this operation. So we need first how we will perform this operation until we reach the null. Okay, so first we need a forward, which is nothing but forward, which is nothing but current next. Why we need a forward? Because when we actually revert this to here, the forward is here actually storing this right value, and this current and previous storing all the left value or the left list. Okay, so we just take a forward. Okay, now the main important step, to pointing to previous the previous node. Okay, so pointing to the previous node, this is nothing but current next, the next of this current or the address of this current pointing towards previous. It will ensure those previous node or reversing our list. Okay, so now increase our previous to current. Okay, and increase our current to forward. Okay, so now which is our current head? Our current head is previous, because previous is our current head. Why not the current? Because current pointing to this null and previous pointing to this last element, and we need this last element which is now becoming the first element. Just run it. Okay, we have this runtime error. What's the problem here? Runtime error, member access within null pointer is type list node solution cpp undefined behavior. The next is null. We have all the head is null. Rather, I think we should do this. Rather, I will go and have to debug it, because because when the head is null, we just pointing towards the null to null, because the error happens because the head is null. Null, it doesn't have any pointer. It doesn't have any pointer, and at the starting, we are checking is there is anything or not. So this is not possible. Okay, so that's why we have to check this thing first. If the head is null, and if the head is not null, check there is only one element or not. Okay, let's submit it. Yes, it's working. It's working. It's working. This is a simple P O of n solution, where we n is the size of the linked list and space is big of 1. Okay, and now another solution, which is a recursive solution. But how we can take a recursive solution here? Okay, let's first bring our node, this one, put here. Okay, 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 okay. No, 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 no. So this is our node. Okay, so this is our node. When we actually to think so much, or we don't need three pointers to reverse linked. When we don't need three pointers to reverse a linked list for these two cases, because we just check it here, we just check condition and return it. Okay, so if this linked list contains only one node, only one node, it should point towards the thing, right? Okay, so what if we solve for one case and remaining case is solved by the recursion? Okay, so if we put all of this into a recursion, so let's think is like that. We are at this location, our current is now at this head, and take a size. We somehow push this whole function into recursion. We push this whole function into recursion inside the box, and the last pointer we point it to this two. Is it possible? So if this inside box actually store all the value, and we just push it here, so we just inside the box we just take all of our work to recursion. that do our work. We don't think. At the end, we just put our pointers to reverse direction. Similarly, if we make a box or put recursion here, okay, and then simply put the pointer here, it is okay. So and suppose for the recursion also, this will also go into the recursion, and this will point. I need a pen. This will point towards outside, which is null. This could be possible. So we are going towards everything, okay, towards everything to the down, everything to the down, and put everything, build up everything using recursion, and just pointing towards the opposite direction. Using this, we can easily do this. Okay, so for this, let's see our visualization. Okay, reverse the rest of the linked list, then make the node after the head pointed back to its head, and head pointers to this null. So we just do it here. Okay, similar thing we do just here. Okay, and the head simply pointed towards. Why I am doing this? Oh, it doesn't have control. Why? Shit. So when we have the head, we just pointed it towards the null. So this is our solution. So the recursion dives to the to the tail first. Sorry, my mistake. Then fix the arrows on the way backing up. Okay. We just do go inside this loop. Then fixing our pointers. So we put our head as 5, and we just fix the pointers. Okay. Now Now we simply fix it. Everything. Everything in fixing in the recursion. Because recursion take all of this and fix it by himself. Okay? Or herself. Anything you want. Sorry for that mistake. Let's write down the function here. In function, we need three things. We need three pointers, we can say. One is head, another one is the current value, another one is the previous value. Previous value is used for pointing towards the previous, current is for the current, and head is for the forward, to calculate forward or the next element. Okay. So first, if the current is becoming null, simple thing, the head will become previous, head will become the previous, and simply return. Don't do anything, return from here. We actually, this is our base case, so we reach our base case. Now we need our next element, okay, which is forward element. So it is nothing but current next, and now recursively call it. So call our function. Now our head changes to current, head changes to head, sorry, head changes to head, and we are just increasing our current. Okay, we are just increasing our current. So now our next call, the current will be our forward. And what is the previous one? What is the previous one? Previous one is simply as current. Okay. And when we back with the recursion, when we back, we have to put the pointers. Okay. So the pointers is current and current next. So the current element next. So every time, so suppose this is the 5. Okay. So this is the 5. We just do everything and come back. Now the 5 next, which is pointing towards 8. We just move it and point towards this 2. So that, for that we are doing this last operation. Okay. This is our operation. And we have to return the head also. So just this is actually our recursive function. Let's just sync it. Okay, the student pseudocode has some logical flaw. Prevent it from correctly reversing the linked list. The current is null, then the previous as the new value head. Does it efficiently update it? Or we have to add the at the end. Just return the head because this should work. I think we have to return our head at the end from the function. Why not? Why not? Not. Okay, why? Just show the solution. It's just pointing a new heads which is taking from the understand what they are doing. So this is something new head. Taking a new head here and at the end return this new head. Yes, this is the mistake. Why it should do this? Because it should work correctly. Let's write down the code here for this one. Okay, this is our function. Now let's write down our code. So first we need two things, the current and the previous. So simply just take this. This simply current which is pointing to head, and also we just take a previous here which is pointing towards null. Then simply we just call a reverse function and it take the head, the current and the previous. Okay, and at the end simply just return the head. Okay, now write down this reverse function. So void reverse, and it take three things: list node head, list node current, and list node previous. Okay, so also we have to make sure we take everything by pass by reference, not pass by value, because if we take everything pass by value, so every time we are actually generating a copy of the linked list, and at the end when we go come back and return this head, it will return this input head also, input head actually. So for that we have to pass it by reference. So what is our base case? If the current is null, then simply just previous towards the head, push the head towards the previous. Okay, and simply return. This is our last index. Okay, this is. So now take the forward is nothing but current next, the next value. Forward is the next value. So simply reverse, reverse, just call the head and the forward, which is the next value. And when we increase our current next value, we have to increase our previous next value. Now our previous next value is on current. Okay, then simply put it current next equal to previous. Okay, so this is our code. This should run perfectly. Okay, okay. I don't see the error actually. Okay, I think this one a mistake. Maybe now work. Yes, it's working. Submit it. It should submit. It is submitting. It will take big O of n, big O of n, because it traverses the whole linked list. Also, it will take a big O of n space, which is a recursion stack space actually. So actually, three pointer is the better solution. But maybe sometime they will ask recursion solution. And now, actually, this code works, but I don't know why they are not accepting it. The current is before the recursive call. Why? Oh, I pressed the evaluation again. This or K. Actually, let's see this. What is state? If the head is null, head next is null, return head. Okay. We don't specify that. We should specify that if head is equal to null, or the head next is equal to null, then simply return the head. Simply that. It should work. Now the next pointer, reverse function call with this head next. The reverse function here. Headness back to null. Actually, we are doing this actually here. Actually, it is a mix up of these two solution. Okay, so if it goes to the solution that I give, it is perfectly working fine. Everything is working fine here. See, same solution. It is working fine. Okay, but if you want to pass, you can go through this solution also. It is also a very nice solution. It just blend both of them into one function. Nice solution. So this is our question, reverse a linked list. Go use this solution. Use this link to get a 7-day free trial. Use this platform by ChaiCode.com. Thank you. Thank you very much.